Hey guys, today we're going to be welding some stainless steel with the GTAW process, also known as TIG welding. And there's some different things about stainless steel versus carbon steel that make it a little bit more difficult to weld, but also a little bit more fun in some senses. And most of these things have to do with the way that it reacts to heat. So there's some precautions you should take, and there's some other things to think about when you're welding stainless steel. The two main things I think that are some of the biggest things about it that make it different, and things that you should look out for, is its high rate of thermal expansion, meaning that it has higher rates of distortion. It expands and contracts with the heat a lot more than carbon steel. And then the other thing is that it has a low rate of thermal conductivity, which means that heat does not flow through it very quickly like you would get in something like aluminum. So the heat stays localized in one area and builds up pretty quickly. So you have to be careful with your heat input. Those two things working in conjunction can lead to some bad results in terms of your distortion, or just controlling that heat input to get good color to your weld, and to just get an overall good quality weld and weldment quality in terms of dimensionally and stuff like that with the distortion. So we always want to keep that in mind. We want to try to keep low heat input, keep our travel speeds up, especially with TIG welding. That can be difficult when you're first starting out, but just keep that in the back of your mind, that we never want to sit in one spot too long and really burn out that stainless, because bad things are going to happen. We're not going to get a good appearance to our weld. We're going to get a lot of distortion. And then also you can actually change the properties of stainless if you heat it up too much, and get what's called carbide precipitation, which it actually will change the grain structure and make it to where the stainless will not resist corrosion anymore. And you can actually get corrosion on stainless steel if you keep that temperature elevated for too long. And we're talking about over like 600 degrees for a period of time. You'll get sensitization or carbide precipitation. And that's where the chromium and carbon move around in the grain structure and leave areas that can be prone to corrosion. So the name of the game is controlling that heat, trying to weld quicker, and just watching out for those things when it comes to stainless. Okay? The other thing about stainless is the reactivity. So, in terms of shielding gas being important, cleanliness being important, that sort of thing. To get real good color to your weld and to just get a good quality, clean weld, it's very important that it's clean. A lot of times in stainless shops, everything is segregated and controlled environment so that there's no cross-contamination. And then your shielding gas is also a big thing, right? So typically, I always recommend using a gas lens setup for your torch. You can use a collet body, you can get away with that, but you're not going to get the color out of it. A gas lens is going to give you a longer, more defined stream of shielding gas and just better quality shielding overall. So that's number one. I would use a gas lens if at all possible. A little bit more expensive than a collet body, but well worth it, especially for stainless welding. And then you can get away with like a size 7 or 8 cup. Depends on the thickness of the material that you're welding, what type of component you're welding or whatever. If it's very, very tiny, you can use smaller cups than that. But for like a big fillet weld like we're doing, it's not really big, but maybe 1/8 inch fillet weld, 3/16, something like that. I'm going to use a size 7 or 8 to start with. And that will typically produce good enough shielding for that. But now we can cheat a little bit and we can go up to a size 10 or 12 really large cup. for a gas lens with that extra layer of screen, and that'll greatly reduce the nice appearance to our weld and be able to get that straw to copper color that we're looking for. So we want to stay away if we're getting really dark coloring to our weld, like a gray or a sort of mottled grayish look to it. That means that we're either putting too much heat into the weld, or we're not getting good enough shielding, or both. The ideal color that we want out of our weld is what we call straw to copper. So like a hay sort of color, like a light color, yellow color to orange, lighter orange. When we start going past that to the blues and purples and grays and blacks, that's where we're starting to put in too much heat, or maybe we're having a little too short of a shielding. So always watch for that as well. So we'll get started doing some welding today. I'll show you a T-joint and a lap joint, as well as a corner joint. And the T-joint will be using 1/16 filler, and then I'll show you a lap joint autogenous, which means without filler. That's another thing about stainless, is that you can weld it autogenously. Thinner materials like 3/16 and lower, I would say you can weld autogenously and you won't have any problems with cracking if there isn't a lot of stress on that joint. So you'll see a lot of small stainless components welded autogenously as well. So we're going to do the T-joint with filler metal, 1/16 filler metal, and then the two others we're going to weld autogenously, and I'll show you those welds as well. Okay, so I hope you enjoy the video. All right, so we're getting ready to weld here. I was going to tell you about my setup on my machine. So we're going to be using DCEN polarity. So that's direct current electrode negative, and that's standard for steel and stainless steel. So we're not going to use AC like we would on aluminum. Pretty much for TIG welding, we're going to be using either DCEN or AC welding. Okay, so that's how we're going to set up our machine. We're also going to be using a remote amperage control, which is a pedal. So we're going to have some variability of our amperage while we're welding, and that's a great thing to have for shop welding in a controlled environment like this, where we can have some extra components. And obviously we're going to be sitting at a table welding, so it's real easy to use the pedal in that situation rather than just using lift arc and not having that remote amperage control. Okay, so that's how we're going to set up our machine. And then the tungsten that I'm going to be using today is a trimix tungsten. This is the laser that I'm using today, and I've used a bunch of the different brands of trimix tungstens, and I like them for steel and stainless steel. They have good properties all around. Low arc starting, they will low amperage arc starting is pretty easy, and they hold their point well. They resist contamination pretty well. So all around, I've come to really like the trimix for stainless and even carbon steel TIG welding. So that's the type of tungsten that we're going to be using today. Okay, the other thing that I wanted to talk about a little bit is the tacking of stainless. And because of that thermal expansion and contraction, the high rates of that, it can be difficult to tack areas that maybe have a little bit of a gap, that sort of thing. When you go to tack a joint, if there's any gap there, or if it doesn't fit up quite properly, like real tight, then you may have to use filler metal. Alternately, of course, if you can if you can straighten out that metal so that you have a good fit up, that's ideal. But we want a nice fit up, because if not, if you have a gap there, as soon as you initiate the arc and start to melt both sides, that weld pool is going to move away from the arc. And so then it makes it just, this thing where it starts melting away and you're trying to chase it, and good things aren't happening for you. So either use some filler metal or try to improve that fit up. Another thing is using the capillary action of the melting of the metal to get a good tack. So I typically, if I have thinner material like this is probably 14 gauge or something like that, and I've got a nice tight fit up, I'll just use an autogenous tack, no filler, and I'll just point right to the intersection of those two pieces and initiate the arc, and then go full pedal real quickly. So if I'm at, like, let's say I'd probably tack with like 70 amps or something like that on this thickness of material, I will point right to the intersection. I'll get the arc initiated, and then I'll go full pedal really quickly. And just for a split second, full pedal. And that produces capillary action. As both sides start to melt, the sudden increase in that amperage will pull those two little small weld pools together. That's the capillary action. They want to merge together with that sudden increase in the current. So that's what I'll do is I'll point right there, ramp up the amperage quickly, and typically it will come right together. Okay, so that's how I tack stainless, and really most materials. Higher amperage and hit that pedal quickly to get it to come together. All right, so let's get started welding. All right, a couple other things I wanted to mention. I'm going to use the size 8 first. So I'm using about 25 CFH. We typically want about 2.5 CFH per size of the cup, right? So 2.5 times 8. So I'm going to use around 25 for this cup. And then we'll do one with a size 12, which much more gas flow, and see the difference in the color and the look of our bead, okay? The other thing I wanted to talk about is hexavalent chromium. So a safety consideration when welding stainless steel is hex chromium, which is a chemical that's released when you weld stainless, and it's just really not good for you. So you definitely want to protect yourself, have a good ventilated area. Fume extraction is the best that you could have, or open air type situation, or like a Papier hood, which is a forced air respirator. But if nothing else, make sure you get a good quality welding respirator. This is my low profile Miller respirator that I use. And, I welded stainless steel for many years in doing like chambers and valves and stuff like that. So I'd kind of be inside of chambers doing welding, and didn't always take a lot of consideration into my ventilation, especially when I first got in the industry. And I have permanent damage to my respiratory system because of that. So really, make sure that you're protecting yourself, especially when you get into the industry and you're new. You think, okay, you kind of, especially when you're young, you feel like you're invincible. But, after 10, 12 years of that, it can really take its toll. So protect yourself, okay? All right, so for our angles, as far as our work and our travel angles, and overall technique with the torch, for just the torch, we're going to use about a 45-degree angle here for the work angle. And the nice thing about holding the torch like this, almost like a pencil between our fingers, is that it's easy to twist this work angle and do an adjustment there if need be as we're welding. Then the other thing is that we're going to use about a 20-degree push angle. So just a little bit off from 90 here, we're going to use about 20 degrees, very slight. And we want to maintain that all the way through the joint without changing it. A lot of times I see welders, they'll start off at a good push angle, about 20 degrees, and then they start to twist their wrist as they go through the weld, and they end up at a very extreme angle, which will give the weld bead a totally different look and give us all kinds of problems. It can also heat up the end of the filler metal and cause it to ball up. So we want to be very consistent with these angles as we go through our joint. The other thing is our angle of the filler metal as it goes in. We want a nice gradual angle here as we dip in our filler rod. And I use my 2 fingers to push it in. And, as I'm advancing forward, I just use my 2 fingers to dip the filler rod. And then I use my thumb if I need some more rod. I use my thumb to push it through. And you may want to practice that when you're not welding with a little bit of filler rod, just when you're sitting around watching TV or something like that. Put a small piece of filler rod in your hand and just get used to advancing it through. That way you develop that muscle memory for later when you are welding, and it will come a lot quicker for you. Okay, so that's my overall technique, and let's get started with the joint. All right, so now that we welded our T-joint, we want to make sure that we aren't using too much heat input to where we're getting melt through on the backside. If you melt through all the way to the backside, that will react with the atmospheric air and can cause contamination to whatever we're welding. So we always want to make sure that, as we're getting our technique down and our parameters down, that we aren't welding too hot or staying in one spot too long to where we melt all the way through the backside. So as we're practicing, if we've got a nice acceptable appearance to our bead on one side, we always want to make sure that we also haven't burned through on the back, because that would be an unacceptable weld if we burn through the backside. So always want to check that. So this one was with a size 8 cup, and now we're going to use this size 12 FUPA cup with a little higher CFH flowing through it, and we'll show you the difference in the color between those two. Okay, so let's go ahead and give it a shot. Okay, so now we had our T-joint with the size 12 cup, and we're running about 35 CFH on this, and you can see that the Strata copper guideline is good here, right? We've got straw all the way through, so that's ideal. Not to say that a weld that is darker than that has some dark orange to blues, purples. I like the look of that weld, but technically that's not ideal, right? It's not desirable. Those welds are probably going to be okay in service, but they're just a little hotter on the higher end side of heat input or possibly your shielding. So this is what we're looking for, okay? So now we're going to do some autogenous welding, meaning without filler, on a lap joint like this, and an outside corner joint like this. Okay, and just because of the thickness of this material, we don't really need to add filler metal. And I can weld this both ways. The lap joint I can weld with filler metal as well, but I'd really want to use some small filler metal to do that, like 035 or 045, because we really don't need to add a whole lot. The top edge of this member of the joint will melt down and will give us a pretty good profile still. So we're just going to weld these autogenous today, but if you were to weld these with filler, you'd want to use probably an 035 or an 045 filler metal. Even 1/16 is going to be a little too much. Okay, so let's go ahead and give those a shot autogenously. So I'm just going to take a moment to go over both the work angle and the push angle for the lap joint, which is going to be a little bit different than what we did on our T-joint. All right, so for our work angle, this is where it's going to be a little bit different. in the T-joint, we were using more of a 45-degree angle as we went through the joint. If we do that on this lap joint, what's going to happen is this top plate, is the edge of that is going to melt away, and it's actually going to go away from us as it melts. And that will make it hard to keep our weld pool consistent and actually melting the two pieces together autogenously. So we want to bring it up to about 60 or 70 degrees to favor this bottom plate a little bit more. And that will make it a lot more easy to keep that weld pool consistent and just push that weld pool across and have it melt both sides. So about 60 or 70 degrees for our work angle. And then our push angle is going to be the same, and that's pretty typical of TIG welding. We want about a 20 degree off of 90 push angle. So if this is 90 degrees, we want about 20 degrees. And then for both of these angles, we just want to keep that consistent, like a robot, going all the way through the joint. As soon as we start changing those angles, we're going to see that affect the shape and you know, the way that our weld pool is behaving. So we just want to keep that very consistent, keeping that sweet spot, and then we're going to have a very, very nice consistent bead all the way across this autogenous joint. Okay, so that's our lap joint. All right, so now we're going to do our outside corner joint autogenously. And we'll just take a moment now to go over these angles again. All right, so for our corner joint autogenous, we don't have anything to rest our hand on. So what I'll normally do is I'll kind of use both hands if I'm welding autogenously. And I just use one hand under my other hand. In this case, you know, because we're welding on a table, if we're actually like welding like a big box or something, then we would actually, you know, rest our hand on the part itself. But in this case, to remain consistent, I'm just going to use both hands, and I'm going to use a 90-degree work angle. Okay, so basically straight up and down to the joint. And then I'm going to use a 20-degree, again, push angle. And we want to keep these consistent all the way through the joint. And you can do this a variety of different ways. Sometimes I'll use both hands and I'll hold the back of the torch as I go through. Just want to keep this very, very nice and solid as you go through. But I also like this technique of just stabilizing my hand with my other hand as I go through. Okay, so that's how I weld that one. All right, so that's our lap T and corner joint in stainless steel TIG welding. Hopefully this video has helped you if you're getting into stainless steel TIG welding, or if you're just practicing at school or something like that, trying to build your skill. I TIG welded stainless for quite a few years when I was working as a welder. So, you know, I have thousands of hours under the hood with stainless steel TIG welding, and have built up that muscle memory. So, you know, it's a lot easier for me now, right? So it's going to take a while for you to build up that muscle memory and get comfortable with the torch, comfortable with your filler rod hand. But once you put in enough hours, it'll all come together, and you'll start to get a really good appearance to your welds and nice consistent look to your welds over time. So hopefully this video has been helpful for you. Please like and subscribe to the channel. It really helps us out to keep putting this content out there.